Hi, I'm Professor Goins, and welcome to the Math Professor's YouTube channel. If you're looking for videos explaining topics in college mathematics, you've come to the right spot, so go ahead and hit the subscribe button and watch the current video. Let's go ahead and get into it. Evaluating piecewise defined functions. Piecewise functions are something that you will use extensively in certainly your pre-calculus and your calculus courses. You might be introduced to those a little bit in your algebra course. Not extensively, but you'll probably start maybe just evaluating them. Once you get to pre-calc, you'll do things like evaluate, graph, transform, solve equations with, all sorts of things, which we'll do in subsequent videos. But for right now, let's just look at introducing a piecewise function and then how do we evaluate those. Because a lot of those other parts of this, like say graphing and solving equations and transformations, all stem from how we evaluate those. So that's the fundamental concept that we need to make sure we get across. First and foremost, a piecewise defined function that I'll just abbreviate as a PDF. Piecewise defined function is a special type of a function, so it is a function which has multiple function rules Now, first and foremost, before I continue that, when we talk about functions in mathematics, again, in sort of beginning math courses, we're not talking about multi-valued functions like you will in, say, your complex analysis course. But when we're talking about functions, we're talking about one input, one output. Okay, a function is one input, one output. Therefore, if I have multiple function rules, we have to use one at a time. And so we also have to have information with this function that tells me when to use each one. Therefore, a piecewise defined function is a function which has multiple function rules along with information describing when to use each function rule. Now, when I say when to use it, I mean not, well, on Saturdays you use the first function and then on Tuesdays you use the second one, something stupid like that. What I'm talking about is regarding the inputs, like when I use domain restrictions to when the input is, say, from this batch of numbers, we use this function rule, but when it's from this batch of numbers, we use this function rule, as we will see. So when I say when, I mean corresponding to the domain restriction. For example, let's say I give you the following, and here's going to be a prototypical piecewise function. So I'm going to use two function rules here, and the first is going to be, let's say, x squared minus 2, and the second function rule is going to be 3x plus 5. Now here's the notation. I stack the function rules vertically. So if I had three function rules, I would list it here, 4, 5, whatever the case may be. And then we use the same notation for a system of equations, so the large curly bracket, to show that those are both connected to the function f of x. Then what I do is I'll put a comma here, and then after the comma, I'm going to describe for which input do I use which function rule. And there can be no overlap here. Okay, I can't say I use x squared minus 2 for, let me put something and then I'll erase it. I cannot do the following. I can't say I'm going to use x squared minus 2 when x is less than or equal to 2, and then this one for x is greater than 0, because in particular, if x is 1, I'm going to use both. If x is 2, I'm going to use both. These two right here have to be disjoint. There can be no overlap between these, because again, a function in our course is one input, one output. I can only use one function rule at a time. Therefore, I could say I'm going to use x squared minus 2 if, let's say, x is less than or equal to 2, and then this would have to be when x is bigger than 2. So that way there's no overlap between those. Okay? If there is, it's just a mistake. So for example, on an exam or something, if this is like x less than or equal to 2, x greater than or equal to 2, then there's a mistake. Go up and tell your professor and they'll fix it. Okay, let's go ahead and evaluate this. If I wanted to evaluate f of 0, what do? Well, first and foremost, my input is the number 0. I have to see which restriction that satisfies. And this should not be a complicated part of the question. It should be pretty clear from the context which one it's going to satisfy. These are not going to be things you have to solve. It's just going to be inequalities that's already solved for example. F of 0. Well, certainly 0 satisfies x less than or equal to 2. Therefore, I use the first function rule only. And this would give me 0 squared minus 2, which is minus 2. So f of 0 for that function is minus 2. Similarly, if I said let's do f of 2. Well, the input is 2. In other words, that's the x value. So what I'll do is I'll look and see which one of it satisfies. Of course, the number 2 satisfies the first inequality. 2 is less than or equal to 2. In particular, it's equal to. Therefore, I use the first function rule, and I get 2 squared minus 2 is equal to 4 minus 2, which is positive 2. Okay? Similarly, let's do f of 4. 4 is greater than 2, therefore I use the second function rule, giving me 3 times 4 plus 5, which is of course 12 plus 5, which gives me 17. Therefore, f of 4 is equal to 17. Notice I did not plug in any of these three cases x into both function expressions. I have to do only one of them. And what I see frequently on exams is, again, this is not correct. Couple exclamation points and some underlines. So that's not correct. Well, that doesn't really show up very well. As soon as I looked up at the screen, I was like, that doesn't really show up. Let me use a different color. There we go. That's more vibrant there. Not correct. If I wanted to compute, say, f of 0, I sometimes see like -2 and 5. They just, sometimes students, they're so have it ingrained in their head that when x is my input, that goes where x is, no matter what. So therefore it goes into both of those. But of course this is not correct. Don't do this. Then I've got one input and two outputs. That's not the type of functions that we are dealing with in a pre-calculus or a calculus course. So don't do this. Do it like I did up here. Okay, let me get this off there. All right, let's do one more example. The red didn't show up very well. Let's do another green one. Okay, for example, like I mentioned before, the number of pieces can be anything bigger than 1. So therefore, let's say I've got 3 pieces here. F of x is equal to x minus 1. If x is negative, it's going to be 4 when x is equal to 0. And it's going to be x plus 3 when x is positive. Okay, so I've got 3 different function rules. The information over here describing when to use each function rule, there's no overlap between any of those, right? Negative numbers, 0, and positive numbers. And therefore, we can evaluate this with any real number. Let's go ahead and evaluate a few. F of, let's say, -3. -3, of course, is less than 0. Therefore, I use the first function rule, giving me -3 minus 1, which, of course, is -4. If I wanted to compute f of 0, well, if x is 0, then that satisfies x equal to 0. Riveting. Therefore, the function value is 4. Right? And then one more, if I wanted to compute, let's say, f of 11. 11 is positive, therefore I'm going to use the third function rule, giving me 11 plus 3, which is equal to 14. Okay? So again, this is just kind of, I wanted to go over the basic concept of how I evaluate piecewise functions. In subsequent videos, we'll do more with this, like solving equations or finding intercepts, things like that. I do have some videos that I posted a while ago on how to transform these things, but again, evaluating them is the first skill that you want to master. Thank you for watching, and please consider subscribing.